All right. Good morning, good afternoon, and good evening, wherever you're watching. So this is a class on MTH106. That is Mathematics for Management Science 2. You've done the first version of it in first semester, which was MTH105. So this is just a continuation. And in this course, you'll be dealing with some things. You have quite a lot of topic to deal with, not that much, but in today's video, I'll be talking particularly on sets, which is the first topic in your course material. Module 1, Unit 1 is sets and subsets. So I will treat that Unit 1 in this video, and then in subsequent videos, we'll be talking about the others. So under sets and subsets, we'll be talking about some things like the meaning of sets, notations, finite and infinite sets. We're talking about equality of sets. Talking about equality of sets, we'll talk about null sets. Then we'll move to subsets. We'll talk about subsets. Under that, we'll talk about proper subsets, comparability, set of sets, universal sets, power sets, disjoint sets, and then Venn diagrams, and the rest of them. So, okay, let me share my course material. Okay, I think that's not necessary. So, the first thing I want us to know is the definition of set. Basically, on daily basis, you as an individual, excuse me, you as an individual, you practice sets on daily basis. Your house arrangement, how you made the order of things in your house is a practical example of set. The general idea of set is it make grouping things, assessing things easier. For instance, if you do not employ the idea of set in your house, you'll find out that there will be no order in your house. Everything will just be everywhere at every time. So TV may be in the toilet, your clothes might be in the parlor. There will be no order, no arrangement. So when you hear the word set, the first thing that should come to your mind is orderliness, grouping. So what is a set? What is a set? Because the definition is very important, so that when you see in the exam that dash is dash, 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 and dash, you'll be able to answer it, that what they're talking about is a set. But generally, you need to understand what a set means in the general form, even before definition. That is why I have to use your house. You'll see that there are some things you kept in the kitchen that are meant for the kitchen. Why? That's because you've employed the idea of set to make sure that the things that are in the kitchen are not found in the parlor. That's orderliness. You are arranging your house for accessibility, for easiness of operation. So when I enter the parlor, I already know things that are meant for the parlor. So when anyone comes to your house and finds the remote, the TV remote in the kitchen, the person will raise an alarm that, this is meant to be in the parlor. Why? In the order of things, in the set or settings of the house, it has already been generally accepted that the TV remote should be for the parlor or the sitting room or wherever. So that is the idea of set. Set means the way you arrange things, orderliness, the arrangement of things, the grouping of things. The best word to use is grouping. When you group things for easy access, for you to be able to easily access them, you are talking about a set. So group of things means set. But what is the standard definition because of the exam? A set is any well-defined list, collection, or class of objects. And I'll quickly break it down. Any well-defined list. A set must be well-defined so that anyone can easily guess the member of that set. In your kitchen now, everything in that kitchen can be named kitchen utensils. So when you say kitchen utensils, anybody can generally guess what will be in the kitchen. While that name, kitchen utensils or utensils, has already been used to define the things that are meant to be in that set. So it has to be well defined. So when you say dining, or maybe let's say dining equipment or anything, anybody can generally think of what will be in the dining. So that name, dining, has already given that set a definition. So a set must be well defined so that when anybody want to list the member of that set, they will be able to do it easily because it has a definition. So a set must be well defined. A set of kitchen utensils, a set of house equipment, a set of office equipment, a set of office chairs, a set of dining equipment, a set of student, let's say maybe student materials or anything. So it has to be well defined. So when you tell me a set of this, once that thing is well defined, anybody can contribute to it and still get what that set contains. So a set must be well defined. If you are forming a set now, excuse me, it must be well defined and it must be a collection. So if I'm saying a set of kitchen utensils, it's a collection of things we can find in the kitchen. So anybody can start guessing. Pot, plate, spoons, gas cooker, electric stove, blah, blah, blah. So people can start guessing what would be in that set. Then, or it can also be class of objects. So in essence, a set is any well-defined list, collection, or class of objects. That's what you should know that. So we have examples of set, like if you say the vowels, everybody know what the vowels should be. The A, E, I, O, U. So it's a set. It's well known. It's well defined. People agree to it that A, E, I, O, U is or are the vowels. Then the alpha of the alphabet, we have even numbers. If you say even numbers, those are the ones divisible by 2. And that's are 2, 4, 6, 8, 10, 12, 14, 16, 18, and so on and so forth. Is a set. So when you tell someone the set of even numbers, the person knows the numbers that should fall under it because even numbers is already well defined. You've defined what you are looking for from the person or what you're asking for from the person. So the person can give you any number that falls under even numbers. So you say rivers in Nigeria is a well-defined list or collection of rivers because anybody can easily mention any rivers that fall within the Nigeria terrain and it will be correct as part of the set. So that is just it. There's nothing hard in set. Just know is what you see, what you yourself do every day. Every day. Your life is even an arrangement of sets. Yes. The way you order your things every day, maybe you wake up, it's all ideas of set. So set is all around us everywhere. So that is what you should know. When you hear the word set in mathematics, you should be thinking of group of things or groupings. So that is a set. And you should know something that the theory of sets is one that lies at the foundation of mathematics. Almost every field of mathematics involves sets. When you want to solve simultaneous equation, quadratic equation, just mention them. you employ the idea of set to be able to solve them successfully. So that is all on set. Now we need to go to some things we need to show ourselves on set. How do we represent set? Set notation. And on that, I will stop sharing my screen because I will need to write now. So we'll go to, we need to go to writing now. So you will give me some time to set that up. Give me some time to set my whiteboard up so we can start. We want to enter set notation. I believe you know some things about set now. A set is any well-defined list, collection, or class of objects. And also, a set lies at the foundation of mathematics. A set lies at the foundation of mathematics. A set lies at the foundation of mathematics. So I will just wait for it to load my screen successfully. And as soon as okay, so I think my screen is somehow visible now. So that is it. So we'll enter set notation. That's the next thing I will be talking about, set notation. When we talk about set notation, we need to start writing now. Set notation. That is what we want to talk about here. Now, you've heard that a set is any well-defined list, collections, or class of objects. And then you've learned that a set is at the excuse me, it's at the foundation of mathematics. Okay, that is very correct. Now, how do we represent set? When you see a piece of writing, how do you know if it is a set? Or what differentiates set from every other thing? So what differentiates set from every other thing? Now let's go to set notation. That is the way in which set is represented. We have two basic ways that you'll be talking about in this course. But generally, let us look at what a set looks like. For instance, if I have a set, let's name it A. And that set is a set of odd numbers. So we'll say that A is equals to curly bracket open, odd numbers 1, 3, 5, 6. Oh, sorry, 6 is not part of it. That's a mistake. 5, 7, and so on and so forth, the odd numbers. And then we close our curly bracket. Now, this is a set. This is a set, but we'll be doing some, oh, sorry, no, that is. We'll be doing some analysis on this. You will see that we have several things here. We have A on this side. We have equals to in between. We have this bracelet or curly bracket. That's the name. We have items that shows what the set is all about. Element of the set. things that the set contains, we have them. And then we close the curly bracket or bracelet. This first A is the name of the set. There's a set name. The set name is always written in capital letter. That's the first thing you should learn. The name of the set is always written in capital letter. So if you are representing any set, the name of the set itself will be represented in capital. So if I want to say, let a set be the set of kitchen utensils, and I want to use the word capital letter K to represent the kitchen utensils. To write that K, I have to write it in capital letter because that is the name of the set I'm representing with capital letter K. So the name of the set should be in capital letter. This equal to sign is only telling you that A on this side, which is the name of the set, is the same thing as what is on this other side, which are the things that A gave birth to or contains. It's just like A here is the father, and everything on the other side represents the children, the offspring, what A can give birth to, what you can find inside A, what you can get inside A. So that is set notation. A set name, the equals to means contains, A contains the following things on the other side. This bracelet, or we'll call it bracelet or curly bracket. This one, we'll call it curly bracket, curly braces or bracket, anyone you call it. Now, that is the one we use to represent the element, the collection of a set. So if I see something like this, for instance, if I see A is equals to this kind of bracket, 1, 2, 3. This one is not a set. A set uses the curly bracket. So the first thing that shows me that this thing they're asking me is a set is that apart from the name of the set on this other side, excuse me, and the equals to sign, the items, the element of the set must be listed inside a curly bracket, not just any type of bracket. So if it's not a curly bracket, then it is not a set. So please bear that in mind. It has to be a curly bracket before it will be a set. So let me clean that one because that is not a set. Now, let's move on to more important things that we'll be dealing with here. So if that is curly bracket, then we have the items inside the curly bracket, the 1, 3, 5, and 7 in this case. Those are what we call the elements. Oh, sorry, that's not what I want to use. That's not what I want to use. Why are we here? Sorry. No, excuse me. So now we have this 1, 3, 5, 7 as the elements of the set. So the elements of the set are things that make up the set you are dealing with. The things you can find inside the set you are dealing with. For instance, if you have a box in your house or a wardrobe section in your house that you name office wears, which means the only thing you arrange in that part of the wardrobe are your office wears, the clothes, the dresses you put on to your office. So let's use the word capital letter B to represent office wear. So the name of the set will be capital letter equals to, when you open the curly bracket, you start listing the type of materials or clothes or dresses that you can find in that wardrobe. So the packed shirt, the trousers, the suit, the tie, and so on and so forth. All those things that part of the wardrobe called office wears contains, they are called the elements of the set. So generally, a set contains the name of the set, and equals to sign to show the relationship between what you wrote here and what you wrote on the other side. And the bracelet or the curly brackets, which shows that this is a set collection, and then the elements that are inside the set, the things that make up the set. Generally, this is what a set looks like. Generally, this is what a set looks like. So this is a general representation of a set. Don't forget that what we are here to do now is set notation. How can I represent set? Our main focus now is set notation. How can I represent a set? How can I represent a set? That is the next thing we will be looking at. So we have two ways of representing a set. This first one we've just used for example. Okay, let me not use that. Let's just write afresh. Now, under set notation, we have two ways in which you can notate a set. We have two ways in which you can notate a set. We have, now let me start again by writing set notation. Now, under set notation, we have the first one, which is the tabular form. The two ways you learn in this lesson is the tabular form, and the second one is the set builder form. The tabular form and the set builder form. The tabular form and the set builder form. Those are the two ways in which you can represent a set. So I will give us one by one with examples. I'll give us each of them one by one with examples to help us fully understand them and how they work. Now, for the tabular form, the first one, with excuse me, please. So, sorry for that short break. The tabular form is the first one we'll be treating, and we've used it actually in the example I cited earlier. So, we want to treat tabular form. This is a set in tabular form. For instance, if I want to give you the set of fruits that we have in Nigeria, and I want it to be in a tabular form, and let's say I want to use capital letter F for set of fruits. What I will do is, if I say let F be the set of fruit in Nigeria, now represent or write F using tabular form. If that is a question, that let F be the set of fruits in Nigeria, then write F using tabular form. Now, F will be equals to the name of the set. Don't forget, it has to be in capital letter. This is set of fruits equals to, don't forget, When you open the curly bracket like this, then you start listing the elements, the things that make up F. If F is set of fruits, then everything I will write in the curly bracket as elements of F must be names of fruits. For instance, let's say we have mango, and don't forget they will be in small letter. Elements are written in small letter, name of set are written in capital letter. The elements of set are written in small letter. The names of the set are written in capital letter. So we have mango, comma, we have pineapple, pineapple. I think that my pineapple is not correct. Then we may have, let's say, apple itself, then etc. Then you close the curly bracket. Now, this is representing a set in tabular form. This is representing a set in tabular form. What it means is F is a set. And what kind of set is F? Set of fruits. F is a set of fruits. F is a set of fruits. So when you see a set in this form, it is in the tabular form. It is in the tabular form. When you see a set written in this form, this is the tabular form of set, which means this set is in form of, it's looking like a table, is in the tabular form. We have the second type of set notation, how you can write set, or how they can give you a set to be written, which is the one we said, the set builder form. Number 2, set builder form. So the set builder form, excuse me, don't know what's wrong with my voice. The set builder form is the next set notation we will be talking about. For instance, we use an example earlier when I was talking about even numbers or odd numbers. Okay, let's use that example now in set builder form. In set builder form, if you have, let's say they said, let A be the set of odd numbers from 1 to 7. Okay, let me not put condition yet. Now, even the set builder form, we have 2 forms. You have the one with condition. Then we have the one that is just plain, no condition. We'll look at the 2 scenarios. The first one is the one that doesn't have condition. So let's use odd numbers. For instance, if you have the statement, let A be the set of odd numbers. Odd numbers. Sorry, I think I will need to. Let A be the set of odd numbers. What am I going to do? In writing it in set builder form. First of all, you are going to have something like this. A is equals to open curly bracket. Let's use the word X, then this, then X is odd. Oh, sorry, O first. Then close curly bracket. Now, this is how you are going to represent it, and I will tell you what each of them represent. Now, excuse me. Of course, you already know that this capital letter on this side is always the name of the set. So this A means the name of the set. This curly bracket, you already know the work to show the collection of things you want to talk about A to make sure that it's a set. Now, X is an element. What we are saying is, in this case, we don't yet know the things that belongs to A. Like we don't yet know the elements. So we now say, let X be an element of A. This vertical line, up and down line, means such that, now, okay, I think I'll need to label them so that it's you understand it better. The A, of course, as usual, the name of the set. Name of the set. Name of the set. You know the bracelet bracket, you know the meaning, you know the equals to. So this one is just, you read it as equals to. A is equals to X is a possible element of A. Any possible element of A. You understand? X is any possible element of A. Then the vertical line, this vertical line means I think I will need to okay, please hold on.